Hi, I recently picked up a couple of bits of broadcast equipment from a recycling company. And these were really cheap. I can't remember what they actually cost, but it was not much more than the shipping cost. I thought they might be interesting to have a look at, both electronically, but also some of them. There's some quite interesting mechanical construction. These are both sort of designed to go into like big system racks, so most of the interesting stuff is actually on the back end. So let's take a look at these. Basically this top one, this is a box for converting between fibre and coax for digital video signals, and the bottom one is, I think, some sort of encoder for generating, I think, MPEG from digital video. There's all sorts of various inputs and outputs on that, so let's take a quick look at them and see what's inside. Right, let's take a look at this one first. This is a Flashlink box. And this is basically a box containing various different media converters. I think this has got conversion between SDI, digital video and fibre, and there's also an Ethernet to fibre converter. And this is a modular system. I don't know whether these modules are user swappable or whether you have to order it in a certain configuration and then they factory configure it. But it's clearly sort of a modular system available in various different permutations. There's also a fibre multiplex, a combiner here. And this is basically a purely optical device. There's no electronics in it at all, and this basically splits a signal into multiple wavelengths. I'm guessing there's probably a prism or a diffraction grating or something there. So the idea is you can take several different signals on some fairly narrow wavelengths and send them down a single fibre. Now, one thing you notice on both of these, so these are designed for sort of 24/7 operation for sort of TV studios and so on, and on both of them there's no external on-off switch, because obviously these things you just turn them on, you wouldn't normally want to switch them off during normal operation. This one does actually have some internal switches. The other thing about this one, it's got two power supplies. There's two completely independent power supplies, so that allows for redundancy. Again, you don't really want your entire TV station to go down if there's a power outage, so you typically maybe connect these either to two completely different supplies coming from different phases, or maybe one to a backup supply, and they'll sort of switch over. And you can also, I imagine you can probably also hot swap these, so if you get a power supply go down, you can take it out, replace it, while the system is still all running. It looks like there's also some facility for some DC power, so that's maybe for some sort of backup, a DC backup power supply. And it's got there's an RS422, which I think is just used for like system management. Each of these units are pretty much self-contained. There is a backplane in there, but I think that's only for power and probably just some simple monitoring. There's no, the video data doesn't go down the backplane. They're just self-contained converter modules. There's some quite neat construction techniques in this. Firstly, sort of the cover comes off nice and easily. You don't need any screws or anything. And the first thing you see is these front panel LEDs are just light guides, so that you've actually got LEDs on the PCB itself that then go through these light guides to come up to the front panel. So regardless of what modules you've got in here, the front panel stays the same. And again, there's a couple of light guides here for the LEDs on the power supply. And you've got the two power supplies here. There is an on-off switch on there, but say it is internal. These just come out. And you've got quite a neat little power supply module. There's no fans in this. This is obviously designed to go in a rack where you've got like vertical airflow to cool it. So you've got air coming through the top, and then you get good airflow over all the cards, good airflow around these power supplies. And this is 5 volts at 6 amps, minus 5 at 1 amp, and plus minus 15 at 1 amp. And these sort of plug into this backplane, and there's actually for the mains, there's actually a sort of separate connector up here for the mains, so the mains doesn't go on the main board. And then there's a backplane. The actual rear is not a single backplane. I'll show you that in a minute. But along that bottom edge, there's a sort of small board with these 0.1 inch pitch connectors, which effectively forms a backplane for power and probably some communications. All these boards just obviously plug in and out. I don't know if they're designed to be hot swappable or not, but obviously for something like this you want to be able to sort of easily swap modules out for very quick repair and fault find, maintenance purposes. This looks like the main controller board. It's actually got a sort of moderately powerful processor in there. There's a Xilinx Spartan 2 FPGA and an Intel PX-A255 processor. Combat flash card, I've had a look at that. I can't see anything obviously interesting on that card. And this process is probably overkill, because I think all this is doing is literally just monitoring these things and doing some simple networking, so the whole system can be monitored and controlled remotely. So I'm guessing this process of CAD is probably quite significant overkill for what it's actually, the job it's actually doing in this thing. But obviously there might be other versions of this that need more processing on them. Not quite sure why they want an FPGA on there, although again that could be flexibility. They sort of stick it on there so they can do stuff they haven't thought of yet for future upgrades. An Ethernet Mac on there, again that'll be for remote control and remote management. And the rest of these boards are all fairly simple, sort of basic media converters. This one's Ethernet, so we've got some the fibre sort of transmitter and receivers on here, an Ethernet controller. There's actually a PIC on there, and again I'm sure that probably isn't going to be handling any of the data. That's probably again just management and monitoring information about the state of the link, data quality, that sort of thing. And there's a few little dip switches on there for configuring it. And we've got these two fibre. These sort of looks like discrete, presumably a laser diode and a photodiode, with a Maxim Max 3867 on that one, and Max 3264 here. Looks like that's mounted on a little hybrid module. So this is a 2.5 gigabit laser diode driver, and this is a 2.5 gigabit photodiode receiver. This card says SDI OE. I assume that means optical to electrical, so I'm guessing that's fibre input and coax output. Unlike the other one, it looks like both these are the same, so it's the sort of one-way interface. Of course, your video feed, you'd expect it just to go in one direction, so it probably makes more sense to have a single board that's got two transmitters and another one, two receivers. So we've got these little dual modules with the receivers on, and there's some chips made by Genum. Genum seem to have pretty much cornered the market in SDI, sort of digital video. Pretty much any kit I've ever seen with SDI has got Genum chips for sort of transmit and receive. So these are sort of custom chips specifically for that application. And the connector on here goes onto the little backplane for the coax connector. And again, we've got a micro in this case. We've got an 80 Mega 169. A few configuration switches. Again, all that's going to be doing is sort of configuring and monitoring, maybe doing sort of perhaps power control or something. The actual data isn't going to be going anywhere near this sort of fairly low power AVR. So this is sort of the other side of that, which is the electrical to optical. So we'll have sort of a couple of laser diodes here, a couple of Maxim controllers, sort of drivers rather, some multi-turn trimmers there for probably setting sort of the laser power output, and again we've got this 80 mega for just management and the like. There's a few configuration controls on there, and this one actually is marked HD EO, so presumably this is for HD video, and this has actually got an additional, compared to that first one, which are these areas unpopulated, these have actually got these additional chips populated here. But apart from that, it looks pretty similar. Also, it looks like some power supply, a couple of switching regulators down here. One thing that's quite neat about this, although you've got sort of cards going into this backplane, the way they've done the backplane is actually quite neat. Instead of just having a single board, it's actually modular. So each board has got its own corresponding little backplane PCB. So obviously they can just build a rack by using the boards and the whatever permutation of backplanes and blanking boards they need for a particular complete configuration. So these are quite difficult to get out. These have got sort of EMC fingers on the edges of the boards to sort of give a sort of complete shield, so they're a bit difficult to get in and out. But basically the board actually plugs in. We've got these basically optical back-to-back connectors. All these are just mechanical couplings, no active parts in there at all. So the board plugs in, so that you get the optical connections and the data connections to the all these whichever rear connectors the board has. And there's these pins which I've just managed to bend, which plug into this little connector on this very small backplane board that just transmits power and data to the main processor. So it's just quite a neat way of doing a very flexible modular system. So they're using PCB for the back panels. So there's a whole variety of different ones for the different functions. So that's the backplane for the main processor board, which has got some COM ports, Ethernet, and RS422. And this is the one for the power supply. Again, we've got some RS422s. I'm guessing the 422 may be what's going down this backplane. So it may even be that there are some versions of this where you maybe don't even need the processor board. Perhaps the backplane can just be daisy chained using these connectors across several racks. I've not looked for any documentation on this. So on this end will be the one that all of them have, because obviously the power supplies are here. Well, actually, having said that, it may well be that you can extend this sort of using one power supply in one rack, and because we've got these DC in and out connectors, perhaps you can actually have a second rack that also shares the power supply, just to expand it. So I doubt these use a huge amount of power. So maybe you can actually have a configuration where you've got one power supply or one pair of power supplies running multiple racks. Don't really know. It's probably designed to be fairly flexible, because I'd imagine these are the sort of thing where you order exactly the permutation you need, but although you might be able to fit other bits later. But obviously almost every setup is going to need different permutations. So yeah, that's the rear for the power one. So we've got these connectors going down to the back plane, these being the DC coming off the back of the power supplies, and then we've got the mains that's been lifted off a separate board, so it's completely isolated. Sort of the mains AC connectors coming in and then going into these connectors in to provide the mains into the power supply. But I'd say electrically not that interesting, but I think the actual mechanics are actually quite nicely designed for this application. You've got a very flexible way of producing sort of nicely modular system. The whole back panel is, if they wanted to produce a new device, they just need to do a new back panel, and they could just plug it in and have it work with all the old things. So that's quite a very nice example of a really good sort of modular design. And the only other module is this wavelength combiner. This doesn't unplug from the front, and it's got labelled Course WDM, which will be wavelength division multiplexer, channels 1 to 8, and this is a table of the wavelengths and a simple diagram. And what we have in here is a bunch of these fibres going into this little block. So let's see if we can see what's inside. I doubt it will be hugely interesting, but I think we need to find out. This is a sort of fairly solid looking block. It looks like there's probably a laser or electron beam weld around this seam. And I'm guessing these are being glued in, so I think we might have to get fairly violent on this to see what's inside. Well, I've done a whole cutting disc and haven't come across anything that isn't metal, so before I completely give up, I'll just try one attempt at more extreme violence. That was easy. It looks like I just hadn't quite cut through far enough. Obviously this thing is sort of fairly solid, because this precision optical stuff needs to be held very, very stable mechanically. So we've got this sort of basically solid block. In fact, it looks like this is actually just the cover, but a fairly thick one that's been welded on. So we've got this block, and there's a piece that goes here. So that was we've got the fibres sort of coming in here, and then we've got this piece, and another one of these clear bits here. So we've got some sort of optical voodoo going on here. So these look like these are sort of maybe little prisms or diffraction gratings or something. Not really clear how this all works. It's got some extremely very, very shiny surface there. So this part, I think the fibres sort of come in this way, and there's what appear to be some sort of tiny weeny little sort of parabolic mirrors thing that sort of bounce it sideways. So this looks like, yeah, so that goes on the side there, so it's sort of probably turning it around through those mirrors, then into these. I'd imagine these might just be dielectric filters, because they're very narrow band. I'm not really sure how it gets on. There's some sort of cavity down the middle. I'm not really sure how they do the sort of the commoning up. You know, getting the light, sort of splitting the light into all the different directions. I can't really see where it goes from here, so it's not. Well, it looks like there's a sort of clear path through, but as this was like a sort of 1 to 8 rather than just sort of several filters, I'm not really sure how all the sort of commoning up side of things happens. But, yeah, so don't really know about that. Maybe if someone knows about these things they could comment, but it's very shiny. Right, let's take a look at this. This is an NDS E5424 MPEG-2 encoder. I've powered it up. It shows a few error messages on there. I'm not particularly interested in seeing if this actually does anything. Rather a lot of fans in the side of it. Again, no on-off switch and a single power supply. And this is basically made up of 2 boxes. There's like a top box here, and then there's a lower part that's got 3 plug-in cards. So we've got like a sort of backplane and power supply at the bottom, and a sort of top. And this sort of top, which is like a sort of separate unit. Most of what's in this top box looks like it's actually a decoder. Maybe the idea is that you encode the video and you can then monitor it by decoding it again, or maybe it's also, you know, other applications where it's used in as 2 separate units. There's another front end sort of board here. I'll show you where this cable goes in a minute. And then we've got this great big board in the middle. But helpfully, there's a few legends. For example, this IBM chip. This thing will focus. Actually says MPEG-2 decoder, and there's a few other chips. There's a couple of SGS Thompson Dolby MPEG sound decoder chips. There's a few other fairly big chips that I can't find a great deal of information on, but again they're probably going to be decoder chips. And there's a few odd bits of memory and stuff on there. On the back we've got some audio outs on XLR connectors. And some analog stuff down here, some analog devices SSM series. They're probably differential line drivers. There's a couple of relays, again probably for signal routing. Got quite a few capacitors. I think this board also handles analog video out. There's analog devices. There's presumably a video DAC there. And further over here there's quite a few relays here. Again, that's probably sort of signal routing and configuration. Little shielded area in here. And who's in here? And that's again a chip by Genome, so that's probably going to be handling SDI, digital video in or out. And over here we've got power supply. We've got sort of some supplies coming in from the power supply in the bottom section of the unit, and then a DC to DC converter and a bunch of linear regs. Again, obviously for audio they want a nice clean noise-free supply, so we've got these sort of various linear regulators supplying the analog stuff. And there's another board here which I think is probably the sort of main user interface and processor. We've got a 68306 processor. This is sort of fairly old, still got a Motorola logo on it, not Freescale, and a couple of parallel flash, some RAM, just some general I/O stuff. So that's probably a sort of fairly general purpose control board. Look at some date codes. We're seeing sort of about 1999, so about sort of 15 years old. So this is probably sort of obsolete, so it probably isn't HD, so it's sort of probably fairly obsolete, sort of standard SD video stuff, which is probably why it got recycled. There's a few more bits underneath this power supply. There's a couple of RF boxes. There's a IF up converter from input 70 to 140 megahertz output, sort of local oscillator 10.07 gigahertz, and there's like just a sort of some sort of splitter or combiner. So it looks like a signal can be looped through here, tapped off, and then goes off out of this back pole and then loops into the receiver. So that's sort of just an additional bit they've stuffed in the same box. There's quite a neat little mechanical detail the way they've done this. I'd imagine they probably do various permutations of these sort of cases in different stacking things. So what they've done is the top is fixed to the bottom box using these Allen screws, and you can actually get the Allen key through the screw hole that holds the top cover to actually undo that screw. So you can stack these up and actually sort of screw them in from the top using the same screw positions all the way down, which is quite a neat way of doing it, without having to mess about with offset screws and so on. Unfortunately, the size of the hole in the top of the Allen screw is smaller than the screw hole above it, so it's quite a neat little solution. And this down converter isn't hugely interesting. There's just a little bit of RF voodoo in there. Looks like this lead's a bit of a sort of an afterthought. But again, that's just it's an off-the-shelf RF module. And underneath here we've got the main card cage. We'll look at those boards in a sec, and a rather massive power supply. And this looks like a modular power supply. We've got sort of slots on the output here. We've got 5 volts at 60 amps, 3.3 volts at 60 amps, and then some other supplies, a couple of 15 volts at 8 amps each. Right, this is the backplane assembly, very solidly made. Obviously you've got 3 of these 96-way connectors, so you've got a fairly massive insertion force. So the last thing you want is your backplane to flex. So we've got this sort of folded stainless steel mounting bracket, got the power bus bars for our 3 and 5 volt, 60 amp supplies, and the PCB itself is a 3.2mm PCB, so it's nice and rigid. So this thing is seriously sort of really rigid and solid. I mean, there's just no movement at all in these, which is exactly what you want, where you're sort of plugging in these monster great cards into it. And of course, being sort of expensive professional gear, all these cables are made exactly to length. Every single bit of cable's got its own little heat shrink thing identifying its sort of drawing number, issue number. For some reason they seem to have got issue 2 on this single piece of wire, and so all these backplane cables, again, they've all got their own little drawing numbers on them. There's a few odd little bits and pieces on this backplane, a couple of FETs here, which I think is for controlling some fans, a couple of 12 volt regs, a few odd little bus buffers and so on. One interesting detail, they've got a couple of these connectors. These are actually sense connectors for the power supply. Obviously if you've got 3.3 volts at 60 amps, even with like sort of fairly sort of chunky cabling like this, you're going to get some voltage drop. So what these are actually connectors that feed the voltage back to the power supply, and it uses these for regulation, so that the power supply will regulate so that we've got 3.3 volts here, not there, so any voltage drops over the cable can be compensated for. This is very common on high power supplies. They've almost always got sense input, so that whatever cabling you're using, you sense the voltage at the far end of the cabling rather than the power supply terminals to compensate. Right, let's take a look at this power supply. So this is a modular power supply. It looks like it's designed for sort of factory configuration, not end user configuration. It's only because the cover's behind a warranty screw, but it's only one screw. And the way they've done this is actually really interesting, quite clever. So we've got basically all the front end stuff. We've got mains input, the filter, switching transistors, reservoir cap, and all the sort of front end stuff. So for any given size of power supply, this is a sort of 400 watts. This will be basically the same for all power supplies of that power rating. But the way they've handled the modularisation is really clever, because of course with different output voltages you might need different numbers of turns on the transformer. So they've actually made the transformer, the main switching transformer itself, actually modular. What you've got is each secondary is actually a piece of this thick copper PCB, which is sort of wound, goes around the core of the transformer, and it's sort of interleaved. You can see sort of the primary windings going in there, and this whole thing clips together. So basically, at the factory, they can just take this front end unit, whichever permutation of output modules they need, just snap them together into this transformer, and they've got a power supply. All they need to do is just screw it all together and test it, so they can get a very quick turnaround of a very wide variety of different output voltages. There's also there is some feedback on here, so there's a little plug-in connector down there from the front board with an opto isolator, so there is some feedback from these modules back to the primary side. But this sort of transformer thing is a really neat way of handling that. Never seen that before. And so with that, that clip off, so we can actually just pull these windings out. So it actually looks like they may be, instead of using multiple turns, they're just using multiple. Yeah, it looks like each of these outputs is using 2 of these. I don't know if they're maybe just paralleling them up or if they're wired differently. So we've got the sort of alternating primaries and secondaries throughout the core. Surprisingly, these bottom bits are actually riveted on, so you'd actually have to drill the rivets to get these out, but obviously it's designed to go together once and then be reliable, so it's probably not a huge deal. And so all we've got really on here is just sort of filtering inductors. That's maybe current sensing. There's some ferrite around the output that's maybe filtering. No, actually there's a sort of ferrite on the output for the bus bars through here, and also we've got the rectifiers down there, and not really a great deal else in terms of electronics. There's I suspect that might be a current transformer to sense the output current. Let's take a look at these huge boards. This is the bottom one. This has got a number of different inputs. This is the analog video input board at the bottom. There's actually 3 separate boards going to separate backplane slots mounted on a single chassis. So we've got our B and C component video input. We've got some linear voltage regulators, because obviously we want to keep this signal nice and clean, so we need nice clean power supplies, so that's what these are going to be for. There's some relays there. I'm not quite sure why they'd have relays unless they're to maybe get some sort of black reference or something, because there's only one set of inputs. It's not like it's switching between a few different inputs. Then we've got a whole load of analogs, front end stuff. There's some filters here, various amplifiers, and then they'll go and it gets digitized. I couldn't find any data on a lot of these chips. I don't know if they're custom marked or just fairly obscure and obsolete. There's a few lattice CPLDs here, a few chips by Raytheon I couldn't find any info on. And one detail on here, we've got this looks like crystal, but actually it's fatter than a normal crystal oscillator, and there's actually a legend here that says VCO, so this is almost certainly a voltage controlled oscillator as part of a phase lock loop, so that it can lock onto the sinks of the incoming video to produce a sort of stable clock frequency based on the incoming video sync. Something I noticed on a lot of these boards is they've got some Cypress dual port RAM chips, which I'm guessing they're using for communication across the bus. So they've, the processor here can put some data into here that's then read out from another part of the system, and vice versa. So you've got like a little bit of shared memory on each board for intercommunication. And most of the boards have also got these cold fire processors on them, which again will be handling all the various control functions. And this next one says non-DVB data module. What I'm guessing is, and that's just got some D connectors saying sync async data in. My best guess for that is that this is to do with data which is other than the actual vision, so it will be things like teletext and subtitles and other sort of information that's sort of auxiliary to the main video feed. And not a huge amount on here. We've got the the sort of cold fire processor that's on pretty much all of them, and just a few bits of memory, not a great deal else, and some IDT. Those are probably dual port memories or FIFOs. So this will be sort of relatively low bandwidth data. And this one at the end, this is a digital video in. This is for ASI, which is a type of digital data stream. We've got some magnetics at the front end, presumably isolation. Transformers there, a Cypress front end chip. There's an option here for a shield that they've not fitted. And again, we've got the cold fire processor handling the sort of management and so on. Got a big Altera Max FPGA, big IDT dual port RAM. So again, that's just sort of streaming data into the backplane. And next we've got this. This is one sort of fairly large dual board, and there's actually a completely blank board whose sole purpose is just mechanical. Obviously, you still need to have the 3 connectors just to balance the insertion tools when you insert this in the rack. I think if this wasn't there, then you'd run the risk of this some uneven contact pressure. But all this also holds, there's a sort of blanking plate here, so the PCB is also mounting that. But other than that, there's no components at all. It's just a completely blank PCB with a connector on it. This one's labelled video comp module, so I'm guessing this is what's actually doing the compression for the MPEG. There's a chip from C-Cube there who sort of specialise in that sort of stuff. There's a couple of PCI interface chips, not quite sure what those are for. And it also looks like there's provision for 2 of these, so it could be for higher data rates. They maybe use 2 of these chips running in parallel, so you've got sort of the chip and then 4 RAM chips around it, and you've got the footprint for the same again there. These big chips here, these are fairly early programmable logic devices. These are AMD MAC 231 devices, which are E-squared programmable. The reason they're socketed is that these need to go into a programmer to program them. Most of them had labels. I've peeled the labels off to look at the part numbers. So these are sort of in their day fairly complex programmable logic devices. Not vast amounts of logic, but they're also PCI compatible. So these might be interfacing to a PCI bus. And there is a Xilinx FPGA on here as well. Interestingly, using Xilinx here, whereas the other boards have got Altera on them. But it could well be, these are fairly early days of FPGA, so maybe they just use whatever does the job rather than being sort of stuck to one particular vendor. Nowadays, Xilinx and Altera offer fairly similar product lines. But so in those days, they probably had a bit more sort of difference between them. And again, we've got another of these Modular cold fire processors, and again we've got the Cypress dual port RAM for sort of system interface, and the rest is just sort of RAM and logic and so on. So this is almost certainly just sort of processing and compression happening on this board. There's no there's just one looks like just a serial port coming for status, but no sort of data in and out on this board. It's hard to tell. I'm guessing these are probably 6 or 8 layer boards. You can certainly see plenty of sort of track routing on the sets, at least on sort of 2 visible layers from the surface. Just decoupling on the underside of all these. Now we've got this monster big board, and this has got lots of input and output stuff going on here. So we've got audio in here. So that's going to some EMI filters, there's some relays. Again, I don't know if those are for channel switching or muting or whatever. Some analog devices, SSM series analog switches, some sort of a few manual twiddly pots there. Some great big polyester or something. It's they're 470 nanofarads, so they'll be sort of non-ceramic, non-polarized cap, sort of polyester or something similar. And here we've got some analog devices, sample rate converter. So I'm guessing this is handling digital audio in here, going through some sample rate conversion and synchronization and whatever. And we've got a variety of different high-speed interfaces. There's some AMD Taxi chip, which are sort of high-speed serializer chips. And there's some Genome SDI interfaces here. I think the output, the actual main compressed video output comes out of this board. And again, there's options on here for shielding cans that they haven't fitted. A lot of these chips actually had these heat sinks glued on. I'll just pop some off just to see what the chips are. Again, there's a coal-fired processor here. Down here there's some, I think they had some DSPs, which are probably handling the audio side of things. And we've got 5 of these great big Altera Flex FPGAs, and an oven-controlled oscillator for a nice sort of stable time base. And there's a numerically controlled oscillator here for frequency generating, for generating all system clocks. Nice sort of accurate stable clocks. Obviously if you're broadcasting video you want the frequency to be bang on. I think there's also a teletext data processing chip here, so this will be handling that'll be handling the teletext side of things. That's about the only through-hole part on the board. And also just a bit of memory here, so nice huge great chunky board. Little regulator they've bodged onto the bottom there. There's 1 or 2 bodge wires on these, but not a huge amount. Obviously if you're doing a PCB like this, you're not going to respin this board for just a few minor changes. So you sort of expect it on this sort of thing. You know, these aren't made in huge quantities, so you're not going to just bin a board because of a few minor tweaks. Actually, another thought that some of these relays near the panel connectors, these could actually be status outputs. It may well be they just provide some relay contacts out to tell whatever's supplying the data whether the thing's locked or got errors or so on. So that might be another reason for having relays at near the front end rather than signal switching. We saw those on the video input as well. Again, these are going into D connectors, so in fact that connector there says alarm, so it could well be that those relays are just relay contacts out to this D connector for external status, because I think this is going to all be in a sort of big rack in probably an equipment room, so it needs to be able to send out remote signalling for status and so on. And sort of a relay contact is sort of like the lowest common denominator in terms of a simple interface that will interface with anything easily. So another bunch of originally very expensive but now pretty much obsolete electronics. I think I'm going to need to find space to make another PCB wall. Things are piling up a little bit.